Hey guys, welcome to my videos again. So in the last video, I was talking about the robotics advancements that we'll be discussing about and see whether those specific projects are interesting and we can grab some ideas from those projects for our research or maybe something innovative can pop up from that. So today I'm talking about one of the 2024 ICRA papers. By the way, ICRA stands for International Conference on Robotics and Automation, and it is one of the finest conferences for robotics. I would say the best for robotics, and it is organized by IEEE. In 2024, this particular conference happened in Yokohama, Japan, and this particular paper is published or compiled by the University of Tokyo students, specifically Graduate School of Information Science and Technology. So let me share the screen for um, the same. A second. And yup. So here we go. And the title for the paper is Development of the Assembling System for Structure Transformable Humanoid with Attach-Lock-Detach Magnetic Coupling. This I felt like an interesting paper, to be honest, when they use attach, detach, and lock mechanism in robotics, especially in humanoids. There are so many constraints that pop up. First of all, credits to be given were due Tasuku Makabe, Kei Okada, and Masayuki Inaba, the authors of this particular paper. And the abstract says we propose a method to adapt humanoids the ability to change the body structures that modular robots have by using attach-lock-detachable magnetic couplings. They name it ALD mag or ALD mag as I call it, to give the ability to detach and attach the robot body with an arm type robot and the system to manage the connection state of modularized body elements. Robots and we can use the ALDMAC to attach and detach mechanical and electrical connections without actuators. So this particular robot can be detached and attached by humans as well as robots, and they're attaching and detaching electrical and mechanical. Electrical connections are being attached and detached at the same time as the mechanical parts. Using ICRA for writing the file of the robot model description of each module, we can construct a system that allows the robot to attach and detach modules during task operations. We demonstrated the effectiveness of the proposed method by achieving assembly experiments of a small robot with a life-size arm and experiments with environmental contacts by using this small robot, which I feel is really, really interesting and could give rise to so many research works, I would say. And let's skip the introduction part because I'm curious of the implementation part and related works and contribution. I guess we'll look at it later, but the hardware design and system is what I want to look at. Let's understand how they are, uh, you know, playing around with magnetics and electrical components. The robot system proposed in this paper is equipped with TTL series servo motors and multi-sensor boards. The control board, which they've used Condo 7, and the motor sensor devices are daisy chained and have three lines. So daisy chained is in other terms we can say it's a parallel connection. So they have the sensor and motor devices that are connected in parallel and have three lines, which is VCC, the single line, UART half duplex, and GND ground. Since VCC, signal lines, and ground are all connected in the same daisy chain, the control board can communicate with device without depending on the wiring topology, and conversely, it is possible to detect when communication is lost. That's interesting. And what have they used to make the connections? Pogo pins is used in modular robot to modular robot connection mechanism are also used in the system to attach and detach electrical connections. They're using pogo pins, the similar ones uh, where you would have seen in possibly MacBook uh, chargers, or a couple of chargers where you have uh, what do you call the magnets at the end and the pins are right in the middle, which is really really interesting because this one will change the whole lot of stuff. Because now, along with the attach and detach and lock mechanism, you can have those pins, or I would say the pogo pins as they call it, the pogo pins attached onto the device end, where you have the locking mechanism of the mechanical part, and the pogo pins just sit on that particular um, interlocking device. And as soon as the mechanical uh, connection is made, the electrical connection is also made. That's that's very nice idea in that scenario. So the mail board has two types, one with pogo pins added to the surface of the multi-sensor board and the other with only pogo pins and connectors as shown in figure 4. The multi-sensor boards are equipped with four infrared proximity sensors which can be used for detecting the position and number of holes of the female board to detect the direction and type of object being joined. So they are ensuring that while the connections are being made, they're also made in the right direction. Regarding the pogo pins on the male board and the concentric pads on the female board, the three-pole communication corresponds to each of them, and it is possible to maintain continuity regardless of the angle which they are connected. So, although they're giving emphasis on the direction of the connection, they are also making it flexible for the continuity to be present regardless of the angle at which they are connected. So overall, I would say this is a crazy um, idea, although simple, but it is a crazy idea to implement all of those. And they have the locking contacts, female joint, and uh, male joint architecture being shown over here. So overall, I feel like these things will give rise to new inventions and new systems in place of the traditional robotics, because you can see over here that they have so many uh, parts of the robots that are not connected, but these can be connected using the attach, detach, and lock mechanism. At the same time, they are also emphasizing on detection of what um, the end effector module is, which is quite fascinating because once you design the robot and move towards the simulation stage, it is very essential to detect what the end effectors are, because the humanoid hands have too many joints at this time, and the end effector, if not detected properly or if not specified properly as to what end effector it is, the tasks that can be assigned to the robot will fail, and you can't, uh, I would say, fabricate your robot if not the end effector is properly detected, or you can't use it as an end product, or the overall robot can't be used for the task specified. So looking at all of these, I feel like, okay, on paper it looks all fine, but oh, they have attached an image of a robotic arm placing a humanoid in here. Oh, how can I show this? Wait, let me just zoom it in. So they're using a robotic arm to place this. Okay, and once placed, they're, I guess they're actuating the locking mechanism in here, and over here they've modified, as in completed the docking, and the robot then moves, and I guess it has a screwdriver, including robotic assembly. Oh yeah, they have a screwdriver in here which will go and unscrew something or screw something. So overall, I feel this project is so well ideated. In this paper, looking at the conclusion, we propose the ALDMAG mechanism and the system to share and reuse the modularized body information as the method to give humanoids the ability to change the body functions and structures of the modular robots with the ARM type robot. Using ALDMAG and the body information management system, we demonstrated the effectiveness of the proposed method through experiments of partial assembly of the small robot by life-size arm, experiments including movements in the environment and environmental contact behavior. In the future, we would like to construct a method that automatically selects the body elements to be used from task settings and apply the method to robots of various scales not limited to humanoids. That's really an interesting and a visionary goal to set up for themselves, and I really appreciate the authors for their vision and purpose. But I also found one of the videos that they have made. I hope you can see the screen which has the video. I'll keep this in silence because I just want to stop at times, or maybe keep the volume. Keep volume.
This image is the overview of the proposed Structure Transformable Humanoid system. We prepare robot modules divided by magnetic couplings and assemble them manually or with the robot arm for forming real robots. The system generates robot models by scanning connected modules to form the module chain, and we use the model for motion generation and planning. The small main module of the humanoid has a PC inside the body that communicates with the control board. The control board also communicates with the separate modules to create the module chain. The PC inside the body communicates with an external host PC, which uses the robot model consisting of shared modular information to generate the entire motion. The forces between the mechanisms drive the ring to attach them, and the ring structure can be rotated by an external moment to detach them. We evaluated the tolerable forces and moments of magnetic couplings. Communication was interrupted when we applied a maximum vertical separation force.
The amount of experimentation that has gone into this evaluation of durability of ALDMAG is interesting and fascinating at the same time, because they are looking at the power of the magnetic pins or the pogo pins that they're uh, using for the lock mechanism. Also, this will decide the connection, the strength of the electrical connections as well, because without the strong electrical connections, it is not possible for the robot to send and receive signals effectively and without any delays when automating it Totally. So I guess this is crazy amount of work that they've done.
105 Newton. Communication was interrupted when we applied the maximum moments mx and my about 3.5 Newton meter. The allowable moment mz was anisotropic, withstanding a maximum of about 1 Newton meter in the strong direction and separating at 0.4 Newton meters in the weak direction. The probability of attaching success was higher for those without locking mechanisms. Attaching sometimes fails due to the collision between the claw and the locking mechanism. In the visualization experiment, rescanning the device after
This part is what fascinates me. So, as I mentioned previously, I told the end effector plays a vital role because that will decide whether the robot can successfully do the tasks that are assigned to it with the end effector that's in place or joined using those pogo pins.
attaching the electric screwdriver module to the toe allowed detection of the new module. When the hand and arm modules were separated, we detected them immediately. For detaching, we separated the module by applying sufficient torque to the ring by vigorously turning the joint. For attaching, we achieved to attach the modules by simply pushing the magnet coupling downward. The arm robot connects the humanoid robot to the magnet coupling at the end of the arm, transports it, and separates it on the mecanum wheel cart. The humanoid robot detects the mecanum wheel cart by scanning the new module and moves down the hill. After
You saw that as soon as it was attached, the robot detected every part on its body or structure and optimized itself on the simulation software, detected the actuation system that's in place, and accordingly, the movements are decided. This is totally
moving
fascinating.
down, the robot uses an electric screwdriver to turn the screws in the environment until they are tight. It then attempts to return up the hill but falls over on the way back down. We configured the platform capable of validating assembling's task and independent task executions by small humanoid.
Falls on the ramp, falls while climbing the ramp. That's nice. So overall, this was the project that I wanted to speak to you about today. The very first video of the project section. Here it is. Kudos to the team of University of Tokyo, and congratulations on the uh, publication at ICRA. And hope someone gets fascinated and clicks an idea to develop this and enhance this in a certain way where it can be, where this particular research can go ahead. And I also wish all the best to the authors that they have set their vision uh, far ahead from this one. So yeah, that's for the video, guys. I'll see you on another one. Bye bye. I'll stop sharing and yeah, signing out. Bye bye.